Kami ada di seluruh negara. Berkongsi cerita, membawa suara rakyat. Kami ambil tahu, kami ketengahkan. Laporan harian, lintas langsung, semasa dan paling dipercayai. Berita wilayah, medium aspirasi masyarakat.
Welcome to the world.
I used to be chill, now I can't catch my breath. When you say my name, I feel tight in my chest. Can't handle the space, I need you here by my side. You make me sweat in the coldest of nights, yeah. I had control in the driver's seat, but my hands are slipping off the wheel. Now the tables have turned.
Teknikal David, setakat itu saja. Baik, kita nak dia punya semangat tu dibawa sehingga ke generasi yang akan datang.
Malaysia boleh.
FM, asik.
You're like a full moon, and I'm up all night, howling at you. Tables are
pada 20 September 2020. Dan itu adalah satu perakuan pada Universiti oleh Menteri Pelajaran Perdana itu supaya Malaysia menerima cara di mana teknologi digunakan di negeri Jerman dan juga Eropah Utara. Beberapa jawatan kuasa kecil telah ditubuh untuk menggabungkan kedua-dua perkara ini supaya hasilkan sebuah akta teknologis dan juruteknik tahun 2020. Ia mengiktirafkan kedudukan teknologis sebagai profesional dan kedudukan juruteknik juga sebagai profesional tetapi dipanggil bertauliah, juruteknik yang bertauliah.
Malaysian Society for Engineering Technology MISET akan mengendalikan program pembangunan profesional untuk teknologis kejuruteraan dan juga juruteknik supaya Malaysia dapat menghasilkan tenaga-tenaga pakar dan profesional dalam bidang teknologi kejuruteraan untuk membantu negara dalam pembangunan industri dan juga infrastruktur di negara kita.
Memangnya penubuhan MBOT ini adalah satu-satu yang telah kami di sektor pendidikan lama menunggu penubuhannya bagi menghasilkan selari dengan apa yang dikenali sebagai pendidikan teknikal ataupun event. Dengan adanya MBOT ini, maka kelayakan yang akan dikeluarkan oleh institusi pendidikan di peringkat sijil, diploma dan juga ijazah akan melalui proses-proses akreditasi dan juga penilaian kualiti oleh sebuah lembaga yang profesional yang akan memberikan status kepada kelayakan-kelayakan tersebut, dan ini pastinya akan mengubah persepsi masyarakat daripada kelas kedua pendidikan teknikal kepada kelas yang sama rata dengan pendidikan-pendidikan yang lain.
Technician atau juruteknik dan teknologis akan dapat diberikan latihan dan sijil profesional. Selain daripada sijil ataupun ijazah yang mereka dapat daripada akademik, pihak industri akan mendapatkan juruteknik dan teknologis yang terlatih. Dengan adanya MBOT ini, dia akan memastikan standard teknologis atau juruteknik dan teknologis ini setanding dengan
yalah, kita nak suruh dia buat cepat-cepat, dia tak nak buat kan, dia motivate kan.
Saya mengalurkan penubuhan MBOT kerana dengan adanya MBOT saya dapat mendaftarkan diri saya sebagai seorang teknologis berijazah, dan juga saya dapat memajukan diri saya setelah terlibat dalam industri beberapa tahun untuk menjadi seorang teknologis profesional melalui MBOT. Ini satu pengiktirafan kepada pengalaman saya, kemahiran saya dan juga profesionalisme saya.
Sebagai seorang pelajar jurusan teknologi, saya menyokong MBOT kerana saya percaya bahawa MBOT akan membantu program saya untuk mencapai kualiti standard yang tinggi melalui proses akreditasi yang dianjurkan oleh MBOT.
Saya juga merupakan pelajar jurusan teknologi. Saya yakin dan percaya bahawa setelah saya bergraduasi nanti, saya dapat berdaftar di bawah MBOT dan meneruskan karier saya untuk mendapat status profesional teknologi.
Okey, selamat pagi tuan-tuan dan puan-puan. Apa khabar semua? How is your Monday morning today? I hope everybody has a good start on Monday. Alright, I think we should start now. We can't wait for everybody. So anyway, good morning everyone. Thank you for joining us in another edition of Empower Technologies Profession in Malaysia, Pro-Talk Webinar Series 2. This special program is organized by Medialab Alliance Sdn Bhd under the Medialab Academy platform with the collaborations of UTEM, MyRef and MBOT. For information, Medialab Alliance is the technology expert panel for Malaysia Board of Technologies, MBOT, under the technology field of telecommunication and broadcasting. My name is David Chan. I'm from JAA System. I will be the moderator for today's Pro Talk. For information, this Pro Talks webinars has concentrated on academic and industrial point of view and sharing relevant knowledge to all participants. So today we have two wonderful speakers with us. Our first distinguished speakers from the academic is Professor Dr. Zahriladha Zakaria, Director of Center for Research and Innovation Management, CRIM, Universiti Teknikal Malaysia Melaka or UTEM. Professor Dr. Zahra is currently doing research and lecturing in microwave engineering at UTEM and has published more than 300 scientific papers in journals and books. He holds 8 intellectual property rights for his invention and has several international awards for his research and innovations. Congrats, Doctor. His webinar topics for today is research activity and recent trends of RF microwave technologies. All right. Meanwhile, on our second speakers from the industry, we are grateful to have T.S. Ahmad Shafig, Assistant Director at Jabatan Penyiaran Malaysia, RTM. He has vast experience in broadcasting and has been serving RTM for more than a decade. T.S. Ahmad Shafig is part of the highly trained RTM engineer, coordinating and managing technical aspect of most prominent events such as the Olympic Games, SEA Games, Commonwealth Games, and many more. His webinar topic today is adaptations of broadcast technologies during national crises such as COVID-19 pandemic. Very, very interesting. Before we go into our talks, a friendly reminder to all participants, yeah? Kindly switch off your microphones. Like we hear a bit of feedback. Kindly switch off your microphone, thank you. So there's no interruption during the webinar. If you have any questions, please feel free to post your question into the comment sections. We shall read the questions at the end of the webinar. Okay, so without further ado, I would like to welcome Professor Dr. Zahriladha to start his webinar. Professor, ready? Okay, we can see it. You can see the slide. Yeah, can't hear your audio. Okay. Berdengar. Doktor?
Okay. TF David, can you hear me?
Yes, loud and clear.
Okay. All right. Thank you very much. Thank you, TF David. And Assalamualaikum and very good morning, everyone. So first of all, I'd like to thank to the organizer for the Medialab Alliance Sustainable Heart, and also the technology expert panel for Malaysia Board of Technology and Board under the technology field telecommunication and broadcasting. And I think the theme of given by the organizer is to empower technology profession in Malaysia. And I was given about 30 minutes to share about the research activity, especially in UTM. I try to align the talk today with the theme given by the MBOT, especially under the technology field telecommunication and broadcasting. I am Zahriladha Zakaria. You can call me Zahriel. And now I'm attached at the Center for Research and Innovation Management as a director. And I'm also under the Microwave Research Group at the Faculty of Electronic and Computer Engineering and at the Universiti Teknikal Malaysia, Melaka. Okay, let me start. Allow me to give about 1 or 2 minutes about UTM. UTM is one of the 4 technical universities in Malaysia. It's located just about 130 kilometers to the south of Kuala Lumpur, and it was established in 2000, and it's situated in the UNESCO Heritage Site of the Historical City of Melaka. And actually, we have two campuses. The main campus is located at the Duan Tunggal, and the technology campus where we have 2 engineering technology faculties at the technology campus. So far we have more than 50 active collaborations, between UTM and also with the international collaborators. And we are also seeking new collaborators among the industry and also among the local agency in Malaysia. Just to share a bit about where is our campus for those who haven't come to UTM. So this is the view of UTM campus. As we can see, we had the beautiful lake at the center or at the heart of the UTM. And at the bottom, we can see, so this is the location of my faculty of Electronic and Computer Engineering, where the research and innovation activities happen. So today, I want to share about a bit about the research and innovation activities on RF microwave. Before we go further, so this is basically the evolution of phones. It was invented in 1876, and then it has been improved I think in mid 1980s, where we have the cellular phones, and before that normally we had the wired telephone, and I think mid 1980 we had the wireless cellular telephone, and now we have many smartphone with different brands. Not only previously we have Nokia, we have Ericsson. Now we have many other brands of the smartphone. So this is basically the evolution of phones or mobile phones that without engineer, there is no invention. There is no new invention. So what is the content behind this mobile phone? If you open our mobile phone, actually we can see inside the mobile phone there is circuitry. There is an electronic circuitry inside the mobile phone. And one of the major or main component inside the mobile phone is the transceiver. In other words, the transmitter and also the receiver. So the knowledge behind the transceiver or the transmitter or the receiver is the knowledge of electronic engineering. So without the engineer, actually without the electronic engineer, we unable to see the evolution of phones. So that's just a motivation, just an initial motivation of my talk today. Okay. And then we look at, for those who unfamiliar with the electromagnetic spectrum, so today I would like to share about the spectrum in the electromagnetic, where we have the low frequency and then we have the mid frequency until with the higher frequency. So when we talk about the radio frequency or microwave, it occurs between 300 megahertz until 300 gigahertz. So within this frequency, there are many applications, many application of communication, many application of wireless communication, including the radio communication, including the broadcasting, including the cellular mobile phone, including the Bluetooth, and so on. So basically, when the wireless communication, they communicate to each other, the transmitter and the receiver, actually we can't see, we are unable to see what medium they are using so that they can carry the information. Actually, we are unable to see because they carry the information wirelessly. They carry the information based on the wave, based on the wave. As we can see on the right side, actually we carry the information based on this wave. And there are two main components for the wave to be propagated, so that the information can be transmitted from the sender to the receiver. We have two main components. First, we call the electric components, and the second component we call the magnetic component. So by having this electric component, E field or magnetic field, what we call the H field, we can manipulate this wave, and then we can carry the information by using the wave. So our interest today, we want to highlight about the microwave. Okay, how this microwave can be used for different type of application, not only for communication, not only for the telecommunications, it also can be used for sensors and also for energy harvesting as well. Okay, this is just a brief history. The inventor or the researcher who have done the invention or who found out the theory or the invention started with the James Clerk Maxwell in 1864, where he predicted that a couple electric field and magnetic field could travel through space as an electromagnetic wave. And then he formulated 20 equations that were later simplified into 4 basic equations that we use today. So based on this James Clerk Maxwell, now we have 4 basic equation where we use the equation in order to propagate the information within the wave. And later we have the Hertz in 1888 who produced the transmitted and received electromagnetic wave, okay, within 5 meter to 5 centimeter. I think from 50 centimeter to 5 meter. And then later on, Marconi sent the first international wireless message from Dover, England to Wimbledon in France in 1899. And then in 1900, Tesla obtained patents on system of transmission of electric energy, which the US recognized as the first patents on. And also, the Tesla is the first person who described a system of determining the location of object using radio wave. Nowadays, we call it radar. So without the Tesla, we're unable to see the innovation of the radar. The name of the Tesla also being used by the, if mistaken, who invented the car, the electric car, named Tesla. I forgot his name. Okay. And later on, we have other engineers called Frank J. Sprague, J.C. Bose, and also Fleming, who has produced and invention the first practical radio. Okay, without the engineers, we are nothing actually. We are unable to have a new and modern equipment.
Kita punya banting punya.
So this is just a cartoon extract from the Agilent technology, the world without engineers. So we try to imagine the world without engineers, or the world without technologies. Without the technologies, without the engineer, we are unable to invent any type of innovations. Okay, we require engineers, we require technologies to make our life easy. So this is basically about the diagram, the diagram about the microwave telecommunication. Where you can see on the left side, we can call it the transmitter or the sender, and on the right side is the receiver. Yes. And then we have different type of medium of communication. We have the coaxial cable, the conventional way to convey the information. Even though nowadays, for those who are having the streaming, they are still using the coaxial technology. And then the second one, we have the optical fiber communications. Okay, this is I'm not saying the latest technology, but it considered latest in Malaysia. Right? If you see in the Europe, they have this technology for quite some time ago, about 20 years ago. Only recently in Malaysia, I think within 5 years, we have the fiber optic, and then we have the Unify, set by the TM, so that we have a high speed, high bandwidth of communication to the Unify. So this communication, the coaxial and optical fiber, we call the wired communications. And we also have the wireless communication, where we unable to see how the information is being conveyed from the transmitter to the receiver. Okay. This is what we call the wireless communication by using the microwave technology. Okay. So normally we have this base station at the transmitter, and we have another base station at the receiver, and then the transmitter will convey or will transmit the wave, the electromagnetic wave from the transmitter to the receiver. So within the wave, they have carried envelope the information within the wave. So at the receiver, they will receive the information, of course, after we do the demultiplexing and so on. So this is, if you go deeper to the transceiver circuit, we have the antenna here, and then we had the filter, and we have the low noise amplifier, and we have the local oscillator, and after that we had the baseband, where here we may have the signal processing. So this is the conventional or the general block diagram of a RF and transceiver circuit of the wireless communication. This circuit also can be found in any mobile phone. So without the knowledge of the transmitter or receiver circuit, we unable to invent a good mobile phone. So by having the knowledge of this transmitter and also the receiver circuit, we can improve and upgrade the the mobile phone, or nowadays we call the smartphone. So I'm not going to go in detail about the block diagram because it's too technical. I try to share my knowledge as simple as possible so that many people can benefit from this sharing. So, and then we try to explore other application of RF microwave technologies. So here we have different type of application when we talk about the RF microwave technologies, particularly in radar communication, satellite communication, in our smartphone as well, and short communication like the ultra wideband, our television, and our radio. So at my research group, actually we have carried out 4 main research. First, we have developed the sensors based on the microwave technologies. Second, we have the research or innovation on the wireless energy transfer, where we try to tap the energy from the environment, and then we convert the energy to the usable DC voltage. And also we have developed the transceiver circuit for imaging and also for radar communications, and also the latest technology 5G. Nowadays we have the 5G technologies, and also can be used for IoT and so on. Because when we talk about for 5G, actually we talk about the speed and also the high capacity. High capacity means that we can carry as much as possible information within the same time. For example, we want to do the video streaming and so on, we have the high capacity and also the high speed. So basically, my talk today, I will try to give or share the information as simple as possible about the invention or technology that we developed at UTM. And before that, okay, I want to show you about the normal electronic circuit. Normally for the layman people, they say this is the electronic circuit because we can see this is the black one. Some people call it chip, CHIP. Some people call it the internal circuit, and then we can see the resistor, and then we can see the the capacitor, and then the capacitor, this is the variable resistor. And also we have the jumper wire, we have LED and so on. This is the normal electronic circuit. However, at the microwave frequency, since the frequency become higher and the wavelength become smaller, we cannot use this lump component at a higher frequency. So instead using this lump component, we got to use another mechanism, what we call the transmission line. At the microwave frequency, we cannot see the capacitor. We are unable to see the resistor. We are unable to see the inductor. What we can see, the transmission line. The transmission is very easy, like this waveguide, or like this microsweep. However, this microsweep or this waveguide can be represented by this equivalent circuit. Okay. Because at the high frequency, the wavelength is very small. We don't use the normal lump component to circuit for the circuit to function. Instead, using the lump component, we got to use the transmission line. So many people will see, we open the circuit, they will see like a PCB without the electronic components. Okay. This is the circuit at the microwave frequencies. So we try to manipulate this electric circuit at the microwave frequency for different type of application. I will show you later shortly. First, I will focus on the energy harvesting or energy transfer, where actually this figure just to show about there are many type of energy harvesting from the rain, from the heat, for example, and so on. But today, what we do at UTEM, we try to tap the energy from the electromagnetic wave, from our surrounding. We try to tap the energy from the wave, and then we try to convert to the usable DC voltage. So that means we can use the energy. So this is the source of the RF energy harvesting. It can be from the base station, as we can see from here, or can be from our mobile phone, and also from the satellite, and so on. We try to convert it into the DC voltage. So there are many types of applications, such as for emergency relief, agricultural sensors, monitoring for the health, and also battery charging. So these are some examples of application for the radio frequency energy harvesting for monitoring in agriculture sector, where we have many wireless sensor network or nodes, and normally the sensor require battery. And when we had the battery, we need to replace the battery, for example, for every 1 year, for every 2 years, and so on. So to avoid replacing battery, we can use the energy harvesting to power up the sensor, or we can also hybrid the radio frequency energy harvesting with the battery. So we can also produce the wireless charging. For example, we have the transmitter to provide the signal of the Wi-Fi. We can also introduce or invent the transmitter so that the transmitter can be used to provide the energy to charge our mobile phones. So these are the basic concepts that we try to share with the people, and also with the government, and so on. So this is the basic block diagram for the radio frequency energy harvesting, where we have the antenna, and then the antenna is used to tap or to receive the energy, and then we have the matching circuit and rectifier to convert the radio frequency energy to the DC voltage, and then we have the charging circuit, and then this is the battery where the application comes. Either the application for charging the battery or as a voice sensor node. So this is basically the general about how we can use the energy harvesting for charging or different type of applications. So this is the same thing. I try to skip this. So this is basically the prototype that we have developed at UTEM to prove the concept. So this is basically the comparison with the existing technologies. nowadays we have the inductive method and capacitive method where we need to put we place our mobile phone very close to our wireless charger. However, for the our energy harvesting not yet commercialized, the cost I think low to moderate at this point. The size is medium, it can go up to 50 meter. But now we still working on this. The distance is about I think about 10 to 15 meter. So this is where we did our measurement. If I can share. Oh. Okay, let's see. It's mean unable to play this video. Never mind, I try to skip this. Okay, the second part of my sharing today where we can manipulate the microwave technology to design a sensor. The sensor that we can design can be used to detect any type of material. For example, the liquid, solid, food, and in fact bacteria and the virus as well. So this is the example of the sensor, and this is the equipment to measure the performance of the sensor. So the sensor that we develop actually based on the manipulation of the E-field and also magnetic field component in order to detect the unknown properties. There are a variety of applications for the sensor based on the microwave technology, starting from the agriculture, food processing, until the pharmaceutical industry. So this is a bit detailed on the technical. I'm not going to explain further on this. I will skip this. So this is basically the equation actually manipulated from the Maxwell the Maxwell equation that I explained earlier. So this is the proposed sensor that we have developed in campus, where this sensor can be used to detect meat or unknown meat, whether the meat from the beef, the meat from the pork, the meat from the chicken. We have developed also the sensor to detect the unknown liquid. Okay, can be from the alcohol like methanol, ethanol, and so on. So this is the way how we design the sensor based on the information of the E field and also the H field, where we try to focus on the red color here. That means D is the maximum E field. So D is the most sensitive area we can place a sample under test. For example, we try to place or test meat or the unknown meat. Similarly for this for the liquid, where we have the tube to measure or to determine the type of the liquid. This is where we did our measurement in the laboratory. And this is the further information. Okay, I think I skip this. It's quite too technical. And of course, to validate our sensor, we need to compare our sensor with the existing. So we have proven that the sensor that we developed, the accuracy here is about 93 until 99% compared to the commercial one. Yeah, to skip this. And also we try to compare with the existing and the commercial sensor available in the market. Okay. And this is our sensor. However, take note the cost that we propose here is not inclusive the cost of certification and the enclosure for the cosmetic purposes. The cost might be higher lah.
Professor,
The
sorry
sensor
to
that we
interrupt.
develop. Yes, saya.
Professor, sorry to interrupt. You have about 5 more minutes to go. Is it all right?
Okay.
Yeah, thank you.
Okay. All right. Almost done. All right, thank you. And then the sensor that we develop also can be used to determine for the fruit freshness. We have done our test on the 3 type of fruit: cucumber, tomato, and also the carrot. And then we have characterized to determine day 1 until day 10 what will happen to the fruit. Show you the scientific result. And also recently the researcher from Caltech, California Technology, have developed a sensor based on the microwave technology to detect the SARS-CoV-19 virus. The information of this sensor can be found at this link, where they have developed the microwave sensor where they can place the unknown sample, either the virus or the blood, or based on our saliva, and then we can detect through our mobile phone. So this is the latest technology developed by the researcher based on the microwave technology. We can also use the sensor to detect the DNA, bacteria, glucose level, and so on. In agriculture, we can also to use the sensor to determine the ripeness of the oil palm fruit to ensure the correct way, the correct time to harvest the oil palm fruit. And we have also done our research on the microimaging to diagnose if any abnormality found in our head. And of course, nowadays people talk about the 5G. We still follow the same track, direction set by the international body, venturing in 5G research and innovation, and also the autonomous vehicle, where in the future we may have the full autonomous vehicle in market. However, to have the full autonomous vehicle, we need to have installed many sensors surrounding the car or the vehicle. So I'd like to thank to my students who have done the research under my supervision, doing PhD or master. And most of my students now, they are working in industry such as in Intel, in TM, and also some of them working as an academician in university and also the polytechnic, either in Malaysia or in outside of Malaysia. The rest of my students, I think most of them have completed their study, working for international students. Now they are working in their own country, either as a lecturer or as a industrial expert. With that, I would like to say thanks for everyone for your attention, and thank again to TS David for the invitation.
Okay, thank you so much, Professor Dr. Zahriladha. It was very informative webinar there, and I must agree, Prof, that world cannot have without engineers, because otherwise we won't be talking like this. We should have celebrated International Engineers Day. Okay, great. Thank you so much, Professor Dr. Zahriladha, for the interesting webinar. Now, should you have any questions for Professor Dr. Zahriladha, please post it into the comment sections. We shall read the questions later on after the end of webinar. So now I shall invite TS Ahmad Shafig to present his interesting webinar. TS Shafig.
Okay, please wait a while. I'm handling the slides.
Sure.
Okay, can you see my slides?
Yes, yes.
In the first slide?
Yes.
Okay.
Yep. Nice.
So shall I continue?
Yes, please.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. First of all, thank you to our moderator, T.S. David, and to the first speaker, Prof. Dr. Zahriladha. Just for your information, Dr. Zahri, there are 3 of students, UTM students, in RTM right now under my supervision. So they send regards to you. Okay. To all technologists, academicians, industrial practice, and all viewers in this webinar session. So for today, I will share some information and findings based on the broadcast perspective on technical review adaptation of broadcast technology during national crisis. So this template is actually a new build-up template because since before we already had a template how we manage a crisis, but the different were for this kind of crisis, we cannot adapt such a numbers of audience and we are lack of resources from outsiders. So that's why I try to share some new information here. Okay, this will actually happen during back in 2020. So in the first year of COVID-19 were being known and will be well known throughout the world. Okay, some of the words might be familiar to us and some of them might be an alien word being used, and of course the terms being used are quite different. Feel free to do some fact findings in the internet to do more, to find more information about this. Okay. Okay, just a little bit about myself. My name is T.S. Ahmad Shafig Mirza bin Mansor. I'm as an assistant manager in engineering for News and Current Affairs Department of Department of Broadcasting Malaysia, also known as Radio Television Malaysia (RTM). So my contact number in the slide. I'm graduated from Multimedia University (MMU) in Bachelor of Engineering Electronics, majoring in computer, and further study in my MBA at UUM. During my study, I worked at Business Sales Melaka Telekom Malaysia for 2 years. Then I be deployed as a government officer in ICU JPM, or we call it as an Implementation Coordination Unit, Prime Minister Department, for 5 years. And then I'm coming back to Broadcasting Department in outside Broadcast TV Department for 5 years, handling multiple camera production for a huge trailer. If you can see a huge trailer while you are driving throughout Malaysia. So it's one of my things that need to take care of, which are covered for sports, entertainment, current affair, and other related to program TV content creations. Okay, but for today, we will discuss about one of the national crises that happened since 2020 until today, which is 2019 NCOV, or popular called as COVID-19 crisis. It will declare as national crisis once CPRC, or Crisis Preparedness and Response Center, announced last year. The first case was triggered from an outsider from China is coming to Malaysia through Johor borders last year. Okay. So that is one of the limitations during this crisis is happened. Okay, as for today, we notice the pandemic doesn't go as easy as we expected. While we used to have 0 case, but therefore, since a lot of activities, then it coming back again and again. So therefore, through Minister of Health, we are campaigning the 3C and 3S. Such as avoid crowded space, avoid confined space, and close conversation. And also, we also been educated to practice the 3W, which is wash our hand, giving warn, and also always wear our mask. It also it also need to be used by the broadcasters, especially on the reporters, cameramen, audiomen, lighting-men, and others related personnel related to the field of broadcasting. Okay, this is a sample of how we manage a press conference. As you can see, there is a lot of crowd. there is a lot of equipments, there is a lot of cabling. So this is the thing that we need to avoid. So as a normal method of setup, so this is a sample for it, okay? So if we still proceed with this kind of environment, so we might be, the broadcaster might be one of the carrier of the COVID-19. So that's why we need to crash out some few things and try to make sure the information still be delivered with a new style of environment or coverage. So this is one of the sample. The sample also being given through during the MH370 national crisis coverage. So still you have a lot of crowd required, still a lot of equipment, while actually the main person who do the presentation is only 1 or 2 or 3 persons only. Therefore, RTM were given a task to coordinate some broadcasting requirements, such as include content and technical facilities. During this case, RTM as also as official broadcaster shall also look into escalation of information throughout multiple medium of broadcasting from the private broadcaster. Okay, those are the things that we are being asked to coordinate with. So as you know, one of the big broadcasters in Malaysia are the Bernama, Isu Awani, and also the Media Prima. Okay, the methodology that we use, well, we're still focusing on the press conference. Sorry, is there any issues?
No.
Oh, okay. Because I can hear something or some question need to be asked. Okay, shall I continue?
Yes.
Okay. So we're still focusing on the video conference coverage mode, but since there were special requirements to handle it, we need to redesign a new standard guidelines. So therefore, the standard guideline been redesigned based on a few methods. So the first method that we use are using the environment scanning. The environment scanning consists of a broadcast administrative and procedures. The broadcast administrative and procedures, we will cover off schedulings, promo, public service announcement, and etc. While what we are discussing today is about the broadcast technical requirement. That is also include the power supply requirements, working area, manpower, standard house format, and etc. Okay. Some overview about the conventional way and also the crisis way of handling the press conference, as we can see on the slide. There are some of the difference. The methodology still remain there, but only the numbers of equipment and numbers of crowd being controlled. So before this, on the conventional way, we do the invitation to all the reporters, either local or from the international. While during crisis, we are offering only for the official media. Okay, so as in the picture, you can see there are two media involved on the crisis, which is ours, RTM, and also Bernama. Okay, and from the placement of camera, it doesn't much difference, because since if we official or conventional way, as RTM, we always can get the center of the press conference area, but the only things, lesser equipment involved at our place or at the camera position platforms. And also the placement of microphone, as you can see, variety of microphone compared to the crisis, only 2. And also the method of transmission, audio visual transmitting, and also for the recordings. Okay, broadcast technical requirements. As we know now, social media is dominant in terms of information distribution. But as for this requirement, we still follow the TV requirement. Why we follow the TV requirement? It's because the TV requirement has the highest standards of requirement upon transmission or distribution compared to social media. If the social media, if we comply only for the social media, there will be an issues regarding the quality of audio, visual, and also graphic. If we need to convert it to the TV requirement. So therefore, we use the standard of TV and we reduce it to the multiple platform, such as for the radios, only for audio from TV, and also we can downsize it in terms of the specs or the requirements for the social media. Okay, on the broadcast technical requirement, it been divided into two different parts, which is the first one is on the production requirements, and the second one is on the transmission requirements. On the TV broadcast production requirement, they consist of 5 elements, which is camera system, lighting system, audio system, intercom system, and also monitoring system. While for transmitting, we are focusing on from the venue to the TV station, and from the TV station to the listener or viewer or the social media application platform. Okay, so how we define the standards? Okay, we not creating a standards, we are following the standards upon what we've been follow through. So the first standard we are following from the SMPTE, which can be full name of Society of Motion Picture and Television Engineers Ecosystem. So in this standard, there are 3 different scopes. The first one is acquisition and presentation, infrastructure and media management, and the last one is media delivery applications. Okay. Other than that, RTM also follow another 3 standards beside SMPTE. The 3 other standards that we follow are the IEEE, based on the recommendation practice, ITU, the International Telecommunication Union recommendation, and also for the specific for the Southeast Asia regional area, we are follow through whatever standard been decided through the ASEAN members, through the Asia Pacific Broadcast Union. So in this slide, you can see some of the standard being followed by us in order to produce and also distribute the media information throughout citizen in Malaysia. Okay, next, limitations. As you know, during the crisis, there is a lot of limitations. So the limitation that we require is the time management, since we also don't know how fast it need to be react and how fast it need to be deployed. So the time management were very critical. And also, we also need to follow the procedures, standard operating procedures. It's been designed by the MOH, Ministry of Health or the MKN, and also the resources throughout the days, once our border being closed. So we are depending totally on the local resources, whatever we have in Malaysia, throughout Malaysia. So we need to mobilize it, or we need to use whatever that we have localized. Okay, that's why there are some limitation during the design, but still we still focusing on those scope of production and also transmission requirement. Okay, the first review is about the camera system. During this day, we're using a camera system that is there is a variety type of camera system, but on this kind of environment, we're choosing a camera system with a 2/3" camera head type. 2/3" means the camera head can be attached to a variety type of lens, a variety type of recording machine, and also can be act as an audio mixer and also recording mediums. So that's why we use the 2/3". As you can see, if we do a video press conference, we doesn't know how many presenters relate to the press conference. It might be 1, 2, 3, or more. That's why, and detachable lens or switchable lens is quite useful for the installations and also the variety. Okay, so the first review about the camera system, we use the 2/3" camera system, and the advantage of those type of camera has been mentioned before. Okay, in other words, we also put 1 unit of hot swap camera's head if the main camera have failure or any issues for the main camera. So with that, only the head will change, but the other things can still be used if it required to be changed. Okay, so the first one is about the camera system. So next we will discuss about the lighting system. Although they are a press conference method of presenting, okay, but still we require a 3-point system. Why we need that? Why we need that? Because we need a very clear and enough lighting environment for the cameras, in order to the viewers or the social media viewers can see as clear as it can, as they are in the press conference room. That's why we propose the 3 lighting system, which consists of the backlight, front light, and the key light. So how we can see the difference is like this. Okay, if we only have a backlight, it's only we give a profile or lining of light, while if you're using the key light, there is some of the shadow area throughout the face. If you're using key and backlight only, there is some lower part of our head or our neck being not light up. So the best option is using the 3-point lighting, which is consists of key, back, and also free light. Okay, the 3-point lighting is not based on the numbers of lights. It's a method of the positioning and also the brightness of the light being used. So the methodology only for the 3-point lighting, only the method being used, not the numbers. Okay. The third one is the audio system. So in audio system, as we know, input from audio is come from the microphone. But what kind of microphone is suitable for this kind of event? So for our press conference, we usually use a cardioid and also the for the cardioid for the main microphone system. And if we require a backup, we're using a shotgun microphone polar pattern. Okay, why we use cardioid? The positioning is more specific upwards, and it can cancel unwanted sounds such as knocking on the rostrum or pen, note scratch, or other things, unwanted sounds. So that's why we use cardioid pattern, polar pattern. While for the backup, we use shotgun because the placement is quite a distance. Most of the time, it will place on the either on the on camera or on top of the rostrum, so we can see the details of the picture here. Okay, the main one we will use cardioid ghost neck microphone or cardioid lavalier clip microphone, while for backup we're using the shotgun or a boundary microphone. Okay, if you require it to be mixing the audio, then we use audio mixer. So normally we use it if we require a Q&A session. If not, if it's just a one-way explanation or presentation, it will put directly to the camera system, as camera itself can be an audio mixer, not audio mixer, audio amplifier. Okay, the first one is the intercommunication system. Why we use intercommunication system, or we can call it is intercom system? Because in the complete chain of broadcasting, we require many departments and many people. So a person on field or on site, he or she is not just queue for a single person. It might queue or give an instruction to the for a channel controller, for the social media gatekeeper, or for library archive recording. So it will contact with a lot of people. That's why we need an intercom. But in such a way, it also can be quite not easy to set up, since it were not in the same chain of architecture or broadcast. So for this kind of environment, or during this crisis, we set up a IP phone in the location, while it can be communicated throughout the intercom rings in Angkasa Puri. So therefore, they still enjoy the many-to-many communication. Okay, on top of that, we also still remain using the normal phone line, such as using the PXTN or the GSM phone line as a backup communication. But the limitation is 1-to-1. It's not like the previous setup, it's 1-to-many. And the intercom system are a duplex system. It's a two-way communications. Okay. The fifth review were the monitoring system. Monitoring system is one of the important things. It shall be prepared upon the complete coverage, although it's just used for a press conference. It is used to make sure unwanted audio or visual not being published throughout Malaysia through the TV, radio or social media platform. So with that, the presenter can be viewed themselves, although there is a delay between the live event, also the preview monitors, but it's a good guide for them to make sure they are still in the air, or it can be do other things after that. Okay, so monitoring is one out of thing we need to put into the consideration in order to complete the TV production requirement. Okay, to help in terms of monitoring system, normally they are a personnel called a technical producer to advise or in terms of technical to the presenter, either they are ready or they are in queue or they are finished their press conference. Okay. We finished about the TV production requirements. Now we are looking for how we want to transmit from the location or press conference location to the TV station. Okay, there are 4 mediums of transmission. The first one, we are using point-to-point microwave link. But if we are within Klang Valley, we are using KL Towers. But later on, we might need to use another highest building. So since KL Tower already not one of the tallest building in Klang Valley. Or if outside Klang Valley, you may use TM exchange to deliver the signal from the location to RTM stations. Okay. Other alternative we use a DSNG, or the full name is Digital Satellite News Gathering. But this one also need a subscription from the MESAT because we don't have any satellite. So we are subscribing a signal from the MESAT or other satellite provider. Okay, the most common use now is the IP stream. Okay, since most of the area that we cover will have internet access, either from the GSM or the internet access. So the most popular and easy move is using the IP stream via internet. There are a variety of brands and models outside there. So we also use that if we require it, and if the internet access is good to transmit broadcast quality. Okay. Okay. Other than that, we also in the area of press conference. Okay. If there is a AV line, so we will subscribe from the Telecom Malaysia through the AV fiber tie line. So there is 4 options of transmitting from the location to the TV station. But most of the time, we will use the IP stream via internet. Okay, and we also will advise the organizer, such as Ministry of Health or Ministry of Defense, to provide us an internet access to make sure the stability of internet and also the placement of the equipment is lesser compared to the other method. Okay. Okay, the last one, transmitting to the listener radio and social media platform. Okay, from Wisma Berita Angkasa Puri, we will produce the content, and then we have our own brand and variety of mediums to publish those information. The main coordinator will be from Saluran Berita RTM, which currently only can be previewed through My Preview, channel 123. Beside that, they also will be relay channel through TV1, TV2, TVOK, Sukan RTM, on also TV6. There's a new channel. That one is if the publishing is through TV. But for the radio, we're using the national radio for the Malay language, for IFM for the Mandarin language, Mina for Tamil, and also English for tracks. On top of that, we also have 2 social media platform, which is Berita RTM. You can get it through Facebook, YouTube, Twitter, and also Instagram. Same goes to continuous. Okay, so this is how we publish. But still, we have an issue. We cannot get all the citizens to view through our mediums. So that's why the engagement to the other parties also needed to make sure the information can be distributed as many as it can, as fast as it can. So this is one of the medium for public information distribution. We have through MyTV, SO Unify. For the radio, we are still using FM radio, and for the social media, we get 4 most popular subscriber, or the most subscriber: Facebook, Instagram, Twitter, and also YouTube. Okay, so therefore, as a conclusion, they can enjoy the information through television, FM radio, and also social media device. Okay, for other broadcasters, in purpose of rebroadcasting, we are recommending the signal is go through via MyTV, or so if social media through Berita RTM social media platform. Why we propose that? Because MyTV is the currently only channel that produce HD 1080i50, and also for the Berita RTM, once it's live, is produce a HD signal. But since 1 April 2021, TV1 also currently being broadcast in HD, but only can be enjoyed using Astro platform. Okay. So if the others broadcaster require to do rebroadcasting, or we call it sambung siar, so you might choose these 2 platforms as the best platform to do the rebroadcast. But if, let's say, you require to do a repropose for the documentary, or other than requirement for content creator, they are a fee. We are tightened by the Akta Fee Penyiaran tahun 1988. So it might be a little bit charges for that if it require a content, a full rest content, or a clean feed content. Okay, so this is a workflow for the diagram. So once we know the system, once we know the equipment, then how it interconnected, therefore we design the workflow. So for the National Public Service Announcement, the design is differentiate between 3 different locations. The first one at the PMO office is specifically used for the Prime Minister itself, and it's exclusive for him. The second one, as you know, from the Ministry of Defense, used to do the press conference, is on the third floor of the Prime Minister office. So at there, RTM and also Bernama is allowed, or the official broadcaster is allowed to do the coverage there. While the last one is if it required to open to other broadcasters. There is a huge area in Dewan Taklimat, still in the same complex of Putrajaya, Prime Minister Office. So therefore, it can cater numbers of reporters, which still comply on the distancing of people, 1 meter distancing of people. Okay, so this is the workflow. So this workflow also been engaged through Bernama, Awani, and also Media Prima, how they want to retransmit the content. Okay, in the same time, if it require to be a recorded content, we also design a cloud storage for all other broadcasters to get those information through a file. So actually this one is only a low-res file just for the monitoring purposes. But if you require a high-res, then they need to get approval from the Prime Minister office. Okay. Okay, this is how the setup for the intercommunication panel. So the panel can be communicate either one-to-one or one-to-many. The panel is being designed or been tied in with the MCR, news ingest, and a variety of locations. Same goes to the dial-in. but for the dial-in, as I mentioned before, is only for one-to-one communications.
Sorry to interrupt. Yes, Shafik.
5 minutes
A
more.
few more minutes to go, yeah?
Okay.
Yeah, 5 minutes to go.
Just
Thank you.
finish another few slides. Okay, this is the environment on the first area of press conference in Prime Minister office, specific for the Prime Minister. As we will know, another few days or few hours or few minutes later, it might be one new announcement from him. So this is the location where he will use to do the press conference. Okay, this is how the setup were designed. Okay, the second one is for the official broadcasters. It's in the different place. Okay. So this is how the workflow or the design of the interconnection equipments. Okay, and the third one is open for the other broadcasters. So you can see the distance between chairs. So that's why it requires more space and more area to cater this requirement. Okay. Other than that, this is the area for other broadcasters also, but it's been held in Ministry of Health, not a conference room. It's in a hall, in the Ministry of Health departments. Okay, this is how the setup. You can see the main and backup audio system were designed purposely to make sure there is no failure for the audio system during the announcement of the DG of DG of Health. Okay, as a wrap up, there are a variety of options from the broadcasting technology can be used to produce high quality content, but the quality of the information, quality of audio, visual and graphic will be enjoyed when we are using the right device and from the right platform. During crisis, current or updates information is what we are waiting for. Fake news by the unethical personnel, culprit in the society. Let use official medium to share and distribute those information. And lastly, although we are the official broadcasters, and there are also many broadcasters there in Malaysia, we still need a power of influence to the family, relative, and contact, the near contact. The most effective medium of distribute information. Please spread the words from the right information from the right source. So I think that's all for today from my presentation. I open for any Q&A or let's moderator handle this.
Thank you so much. Thank you, T.S. Shafik. What an insightful webinar. Now we all know behind the scene, it's not so straightforward in any conference. Yeah, so a lot of hard works, a lot of system has to be in place to ensure any live broadcast is running smoothly. So thank you again, T.S. Ahmad Shafik, for webinar. So to all participants, should you have any questions, please you can post it into the comment sections, or you can actually provide any. You can just provide your question over here. Meanwhile, we have gone through some of the questions for Professor Dr. Zahriladha. It seems like most of the questions really answered by Dr. Zahriladha. So thank you so much. So any other questions, please feel free to ask now. We can have about five minutes or so. Just put in the comments. Yeah, anyone? Anyway, if there's no at this point of time, we can. There's also opportunity where if you have a question, you can email to the organizer, and from there we shall send the questionnaires to respective speakers, and we can answer directly to you. Yeah. T.S. Shafik, I have one question. Will RTA implement 4K?
It might be near future, but it's not too near because we are covering not covering the purpose of us is to spread the information. So if let's say one day most of the people can buy the 4K TV, then we consider to produce a content in 4K. but in the same time, we still comply with the international standard. If there is a requirement for 4K, let's say for archiving or something special event such as a Merdeka parade or something like that, we might invest on 4K, but not all the production chain. It's only specific equipment or specific event only. This is my point of view.
Understand. Okay, great. All right, so any more questions from the floor? If not, any more takers? No? If not, then I will wrap this webinar up. And should you have any questions, feel free again email to us. Yeah. Okay, this is the end of our Pro Talk session series 2. A big thank you to Professor Dr. Zahriladha and T.S. Ahmad Shafig for sharing their knowledge and information. As for the rest, we sincerely hope that you had enjoyed today's sessions. We would like to take this opportunity to thank our partners, UTEM, MyRef, MBOT, our sponsors, and organizing committees for making this Pro Talk a success. To all our participants, thank you for joining us today. For the next sessions, the Pro Talk Series 3 will be held in June. So watch out for the newsletter to your email soon. Meanwhile, the e-certificate Medialab Academy organizer shall email to all within 14 days. So till we see you again, stay safe, stay healthy always. Thank you and goodbye.
Bye.
Thank you. Thank you. Bye-bye.
Bye-bye.
Thank you.
Thank you.